Welcome back to the workshop. We want to take another look at an example for a continuous random variable. It's actually the same example, but we're defining the probability measure a little bit differently. So let's take a look at our notes. All right, so we've got, let's see here. The situation, again, is still that we're looking at the Chrysler 200, which requires 16 gallons of gas, or could take as much as 16 gallons of gas, because that's how big the gas tank is. Excellent. So, but in reality, right, it's not that I'm going to just fill it up willy-nilly whenever. The reality is that it's typically about the same time that I fill it up. So what we could do is we could say, well, when does Dr. Reinhold typically fill up his fuel tank? Well, it usually is around when there's only a quarter tank left, partly because that's just good practice, but mostly because in order to get to work and home, it takes about that quarter tank of gas. So if I've got less than a quarter tank left, I have to fill up before I get home. And I would prefer not to do that because gas is cheaper here at home. So I always fill up before I have less than a quarter tank, or usually before I have less than a quarter tank. Sometimes I'll have just over and I can actually drive to the university and back home, and then I have very little gas left, but I made it home, so I can fill up then. So that's the sort of situation we end up with. So it's usually quarter tank or less that I am filling up. So we want to define a probability measure that agrees with this idea. And rather than defining it like we did in the previous example, we can actually define it or the idea of it using a graph. And this is perfectly sufficient for us. It matches nicely with what we'll be taking a look at in the next section. So I'm going to need somewhere between 0 and 16 gallons of gas. And what I can do is 3/4 of a tank being consumed. So needing 3/4 of a tank to be filled up yet. That'd be 12 gallons. And it's usually somewhere in here that I fill up at. So I'm going to say, let's have a high point right here, and it drops down a ways, and then it's pretty minimal along here. And that really should be down to 0 there. And then I can define this to go down like that. So now if I say that the probability, right, the probability that I'm going to need between A and B gallons of fuel, if we say that this is the area under the curve between A and B, where the total area, of course, is 1. Okay, so we could just say that the probability that I need between A and B gallons of gas is whatever the area is here. So if I wanted to talk about the probability that I need, let's see here, 12, between 0 and 4. Right, what's the probability that I'm going to need between 0 and 4? Not very likely, small probability. Compare that to the probability of needing between, let's call it 8 and 12 gallons of gas, right? There's a significantly larger probability here, significantly more area, because this is where I typically fill up at. So we could define the probability measure to just be the area underneath this particular curve. And that's perfect, and that's perfectly fine. For very similar reasons to those outlined in our first example, this is in fact a probability measure. So this does in fact satisfy the 3 postulates for a probability measure. Excellent, and that's all that we needed. So this is another way that we could define the probabilities, which recognizes the fact that I'm not equally likely to fill up when I need just a little bit as compared to needing a lot, right? I'm more likely to need a lot of gas when I fill up. Excellent. So that's all that we have for this section, a nice introduction. we'll move on in section 3.4 in our next video here in the workshop. You guys have a great day. I'll see you again soon.